A practical consideration in creating a highly automated vehicle is that it is an exceptionally complex piece of equipment mechanically, but also from a computer-based system point of view. It's inevitable that different pieces will be put together from different vendors and different supply chains. And the question is, when all those pieces are put together, will the system actually work? This is where system engineering comes in. System engineering will be a required core competence for any company assembling an automated vehicle. This is true even if they make all the pieces themselves, because there will inevitably be different design teams that have to collaborate and coordinate. System engineering includes system-level design, such as requirements management and definitions of architectures for hardware, for software, for power distribution, and so on. It also includes system integration. Each component or each architectural element will have interfaces, and those interfaces have to be matched up so that the overall system works properly. That includes sensors and software and hardware and so on. There will also be significant effort required simply to tame the complexity of integrating so many different pieces in addition to whatever supplier management is required. There will be internal and external suppliers of components that all have to be hooked together, and there will be requirements allocated to each component that need to be assembled and integrated and linked to both component test plans and system-level test plans.